So just to revise our algorithm again, right? So in this DPI of set, we are actually each of the element here. This is denoting a sum, the sum of various combinations possible by including an element or in the array or not including an element. So again, if you see here, when we started with DP0, we have got element of 1. So the possible sum, target sum, if whether we include this element or not include this element is 0 and 1, right? If we don't include this one, then the sum is 0. In the set that we are creating, the sum is 0. And if we include this element, the sum would be 1. So this was our DP0. When we got a new array element as 5, and then we have to see that if we add 5 here in this element, in this set, so either we can include for 1 or not include 1. But for that, we have already calculated the sum, which is possible whether we have 1 or not in DP0. So we already have got 0 and 1 whether for our first element. So once we add this new element, we just need to add this 5 for all the elements we already have in our DP set and see that whether adding this element for each of the sums that we have already computed, that will give me the target of 11. So this is our basic algorithm here, that whatever in the bottom up approach, when we proceed with 0th index to the target index, and in the sum, DP sum that we are calculating, computing in each of the sub problems, if we can reach the sum target of 11, which is the sum by 2 target, then it means that it's possible and we will return it. So this was the algorithm I just reiterated to make it clear. So because this is the most important part. I mean, if you understand this, then this problem is very, very simple. So let's proceed with DP2. So for DP2, again, if you have got this new 11 element, right? So we have to add, because we have already computed DP0 and DP1. So we have to, and this is our sum array for 0 and 1, DP0 and 1. So we'll try to see 11 plus for all the elements which are present already there. So it would be 11 plus 0 and 11 plus 1, 11 plus 5, and 11 plus 6. And here for each of the sum, if we reach the target of 11, it means that we have divided this sub-array, and it's possible to divide the sub-array into 2 sub-arrays having a target sum of 11. So here in the very first condition, we see that it's 11. So it means that it's possible to break down this problem because it's very intuitive itself, right? That in the array, we have already seen that there's one element as 11. So if we just choose this 11 element and in one array and remove the remaining part of the remaining element in the second sub-array, we have already found a solution. So here is what we found a solution already, and here we can return it. But let me just fill it out, that what would be the final DP set here. In the solution, we will just return from here because we have found a target and return true. So, and this, okay, so let's calculate this first. 11 plus 6 is 17. Okay. And then we have to add all of these in this array, in this set that we are maintaining. So we 11, 12, 16, and 17. Because it's a set, we don't, we only have to, like, you choose the element once. Okay, and we have got the 11 already as our solution. So I'll just mark it here just to show that we already found a solution. Okay. Now let's go for DP3. I'm just filling it just for the sake of the understanding of this problem. So for DP of 3, which is the last element, we have got a new element 5 here. So for each of the DP set that we have already computed before, we will add 5 to all of them and add it to the set. And then the final set that we have found, we will see that whether our target has been is contained here in the set or not. If it's contained, then we will just return it as true. If not contained, then we'll return as false. So just let's quickly put it me here. So we have got 5 plus 0 as 5. So, but 5 is already present, so it will not be chosen. So 5 plus 1 is 6. Again, 6 is there in the set already, so we don't have to choose this again. 10 is 5 plus 5 is 10. 10 is not there, so I will include this. 11 is already there. Similarly, is 16. So after adding all these elements, all the DP set elements with 5, we found that only 10, 21, and 22 can be added, which are not present. Other elements are already present there. So the final set would be just including, we need to include 10, 21, and 22 in our set. So this is our final set, and which is after consuming all the DP elements from the array. And in this set, we found that we already found the target as 11, and that's why we'll return as true. So just to reiterate this algorithm again, we start with the first element. We can start with the last element as well. It's our choice, but let's start with the first element. And then we we start with initialize with 0. And whatever numbers that we are encountering, we will add that number with whatever elements we already have present in the set. So for example, in this case, we already have 0 and 1. So when we get 5 here in DP1, we will add this with all the elements already present in the set, like 0 and 1, and see whether the target of 11 has been met or not. If the target has been met, like in this case, in DP2, when we start with 11, and in this case, DP1 has got 0, 1, 5, 6 elements, we add 11 to all of the elements already present in the set. And if the sum is equal to 11, we return as true. Otherwise, we keep on proceeding until we reach to the last element. And the final set, which is created, if it doesn't contain the target, then we return as false, or we return as true. So this is the solution. And in the next video, we'll solve the same algorithm in Java and submit in LeetCode.